Welcome back. I hope you're having an awesome time so far. Our next speakers will be from eSentire. Please join me in welcoming them to our virtual stage.
Thank you very much. All right. So we're here today to give you a little bit of an overview of what we've been working on and how to detect cloud enumeration attacks using machine learning. Let me tell you a little bit about our company first. So we're eSentire. We're headquartered in Canada, and we're a multinational company. We operate SOCs across North America and Europe. We're online 24/7. We have people working around the clock to protect our customers. Right now, we protect about $6 trillion in assets, and our year-over-year growth is about 90%. Just in 2019, we've seen over 2.6 billion indicators of suspicious events, of attacks, things that have had to be investigated by our SOC, and in turn, a subset of those have been investigated by our security researchers. So the two of us, I brought with me my colleague, Samira. She's a security researcher on the Advanced Threat Analytics team. She's recently gotten her master's degree in cybersecurity and threat intelligence from the University of Guelph. And for myself, I'm Tim. I'm the manager of that team. Been in cybersecurity for about seven and a half years now. So we're working on the same team. We're very focused on complex cybersecurity. Our team generally attempts to, if you've ever seen the pyramid of pain, it's a fairly common graphic. We're basically right at the top. We're concerned with TTPs, which are the most complex techniques that adversaries will try to use. So I'm going to give it over to Samira and let her introduce the topic and do the deep dive.
Thank you, Tim. Hello, everybody. I'm glad to be here with you. Now let's get us started. First, I'm going to talk about what was the problem that we wanted to solve. What is an enumeration? In general, an enumeration refers to the process of collecting usernames, machine names, network resources, shares, and services from a system or network. In the enumeration phase, the attacker sets up an active connection with the system and performs directed queries to gain more data about the target. To discover the vulnerabilities or weak points in the system or infrastructure security, and building a map of network and capabilities, the attackers use the information collected in the enumeration stage. A good overview of the resources available lets adversaries plan their next move and pick a target. Imagine somebody gets access to a server. They can then try to find all other servers in the network. From there, they can even start to port scan all servers and try to identify services they run, and etc. Next slide, please. So, what specifically is a cloud enumeration attack? An enumeration attack on cloud environments. Considering their popularity and potential to save organizational resources, reduce cost, and make systems more flexible, cloud environments have become an attractive target to cyber criminals, especially in enumeration activities. They just need credentials or a way to access to be able to enumerate cloud services, permissions, users, and resources with those credentials. um, have access to. Cloud enumerations are highly complex systems. It is easy to make a mistake when provisioning policies or permissions. Not every developer is an expert. A cloud enumeration attack tries to take advantage of potential issues. Here is a simple example. Imagine an S3 bucket that contains business data. By accident, it has public read permissions, which can be found during enumeration, and its data is filtrated. Next, please. One example of cloud enumeration attack would be with an insecure AWS role. If an attacker gains access to this role, they can begin enumerating resources and permissions. From this one role, other roles may be accessible, which can lead to privilege escalation within the cloud environment. This way, a simple read-only for a single resource role may be exploited if incorrectly set up. An adversary could assume an admin role and destroy systems, gather valuable data, or gain access to companies' billing information. Next, please. Another example would be an insecure resource. Weak firewall settings, exposed access ports, many different things may contribute here. We see data leaks and compromised credentials quite frequently. Using this data, it can be quite easy for an adversary to find a resource to log into. This resource may have permissions to access a customer database, encryption keys, or other cloud services. An enumeration of the cloud resources and services will reveal this access. Next slide, please. So, what could be done to detect these enumerations? One of the most appropriate attack detections and identification techniques in cloud infrastructure is based on log analysis. In the detection phase, we need to collect logs and events from a cloud environment. Labeling data as malicious or benign requires analyzing behavior, detecting unusual events, and failed access attempts. But we have to consider misconfiguration too. We have to keep track of the enumeration of services, resources, permissions, and users, and compare to expected behavior. Imagine a team collecting all your logs across all systems. We take this data, enrich it with additional metadata, categorize, and then ingest into the backend. From there, our detection start working on identifying malicious actions and behavior. Next slide, please. Let's come to the actual machine learning part of this talk. Detecting complex behavior through static analysis is extremely complex and time-intensive. In order to have logs indicating a potential compromise, a set of open source red team tools have been used. The training dataset was a combination of those anomalous logs and real-world logs. We continuously retrain our model with new findings. Real-world incidents are tagged as true positives by our SOC team. Then we added artificial data from red team exercises labeled by security researchers. Finally, we trained our model on both. We kept a portion of the data for model verification. Presently, we need more advanced and algorithmic techniques such as machine learning and deep learning to detect cyber threats. Because cloud log files are huge in size, using threat hunting techniques without getting help from machine learning and deep learning algorithms could be time consuming. Deep neural networks that from now on we will refer them as DNNs are capable of mapping nonlinear functions. RNNs, that is abbreviation for recurrent neural networks, as a type of DNNs are used to add context into word vectors. By far, the most popular RNNs are long short-term memories, or in short-term term, LSTMs. They are beneficial in natural language processing and can help in log analysis, considering logging trees as text. LSTMs, owing to the fact that they have memory, they can remember the calculated value so far. Having said that, I have created two different deep neural network models: long short-term memory, or LSTM, and convolutional neural network, CNN, to detect the anomaly. Both models achieved over 99% of accuracy. Now let's hear more about eSentire and ATA from team.
Well, thank you very much. I kind of want to put these findings that we've come to into perspective. So one of the things that we're very focused on as a team and as a company is to provide customer value, of course. This is not just research or interesting things that we do. This is not we have a cooperation with academia to some degree, but our ultimate goal is always to help our customers keep their assets safe. So our team is very focused on integrating with eSentire products or even developing additions to eSentire products. We want to make sure that the customer data that sometimes we already have access to can be used to extract the most value. You have to imagine we have visibility across the network, across endpoints, log sources, cloud environments, and each and every one by itself, you can gain a lot of visibility and a lot of value out of. Where our machine learning and our complex detections really shine, though, is when we go across these log sources. We can say something has happened in endpoint that we can correlate to something in the cloud, and we can extract value from that directly for our customers and say, this is something that eSentire does really well, and this is where you're really benefiting from signing up with us. I have a few stats here on this slide for you. We really believe that the combination of machine learning or software in general and expert people is the way forward. You can't really replace the security researchers and the security experts with software. And on the flip side, you definitely need the software to aid you. So if you're looking at this, we have 6 investigations every minute that come around the clock that comes into our SOC. 35 seconds to begin triage. Our SOC is right on top of these things. If any of our customers has suspicious behavior that's being alerted on, they're right on top of that. We have over 600 confirmed security incidents per day, most of which, luckily, are not super serious to our customers, but they're worth investigating because we always want to make sure that our customers are safe from breaches. These are all the things that we're concerned with and that we want to directly deliver value to. So when we're hearing about cloud enumeration attacks, that's just one piece to the puzzle. It's a very interesting topic, and it's something where we use our security researchers, our security expertise to really put into place something that digs deep, extracts behavior, establishes suspicious, and points out, establishes the normal and points out the suspicious, and really helps our SOC be more efficient in protecting our customers. Having said that, I would like to thank you, and we will be available for questions. If anybody wants to hit us up on email, I personally prefer Twitter. If you want to talk there, you're more than welcome to. Thank you very much.
Awesome. Thank you so much for that wonderful talk. Our audience is giving you a big virtual round of applause. All right, if you're looking for your next session, you can go ahead and check out your agenda and go ahead and find that next session. Also, make sure you're taking some time to visit our AI exhibits, check your connection requests, and do some networking. Thanks so much, and we'll see you around.